Okay. Forces. One of the quite important lessons we have in our syllabus. When we talk about forces, احنا we usually say that we want to find the resultant force. Most of the questions ask us to find the resultant force. One of the most important equations that we will be using in forces is F equals ma. صح? Force equals mass times acceleration. Of course, the force, whenever you calculate the force, the unit must be in newtons, the mass, the unit must be in kilograms, and the acceleration must be in meters per second squared. So forces, F equals ma. F is the resultant force. So for example, if I'm telling you find the resultant force, you need to find the F. You have the mass and you have the acceleration. Also, you need to find a F. F equals mass times acceleration. There's a definition for the force. He could ask you define force. You won't say mass times acceleration. No. If you want to define force, actually, it is the rate of change of momentum. Let's write it down. Okay. It's the rate. Okay. What is the force, شباب? It is the rate of change of momentum. Okay. Rate means that you will divide by time. صح? You will divide by time. يعني هنا you need to divide by time. And change of momentum, so you will find the change of momentum and you will divide it by time. This is the definition of a force. Whenever I ask you define force, you could calculate it by F equals ma, or you could use the impulse equation, which we will discuss later on, inshallah. If you want to find the impulse equation, using the impulse equation, you can find the force. Okay? But if I tell you please define force, defining the force, you need to say that it is the rate of change of moment. Let me write it down quickly. Let me write down the equation for the rate of change of momentum. You can say that F equals m, okay, mv minus mu over t. Okay, change of momentum, which is mv minus mu over t. That's the rate of change of momentum. But we will discuss it later on again, inshallah. Okay, so resultant force F equals ma in newtons. Usually, you'd have a lot of questions involving forces, resistive forces. You have two types of forces. Either it's a driving force or it could be a resisting force. So if I have a car, for example, let me draw my very famous car. Mm, I know I'm Da Vinci drawing, right? Picasso drawing. My very famous car, okay, with its perfect wheels, and of course, we cannot forget about the exhaust. So, this is the car moving. If you have the car moving forward with a driving force of 1000 newtons, so 1000 newtons. So we call this force the driving force. This is the driving force. Stop. What about the opposite forces? The forces in the opposite direction would be air resistance, okay? Air resistance. Okay, for example, the air resistance is, let's say, 200 newtons, صح? And the friction with the ground, which could be, for example, 300 newtons. Whatever, I'm just writing down any numbers. I just need to say that the driving force is always in the direction of the motion. Let me write it down. That the driving force is always in the direction of the motion. Of the motion. Whatever the driving force, or whatever value the driving force is, it's always in the direction of the motion, even if it's moving backwards. For example, the car is in reverse and it's moving backwards. Okay, so the driving force of the car is to the left. مثلا, okay, and the air resistance and the friction will always oppose the motion. Okay, the friction and the air resistance, they are called resistive forces. Resistive forces are always opposing the motion. They're always in the opposite direction. But we have the direction of force, or the direction of the motion, the driving force. And then the air resistance and the friction, they're always in opposing the motion. If you need to find the resultant force for this car, we can say that the resultant force, F equals D minus R. What's D and what's R? It's the driving force driving force minus the resistive forces. Resistive forces. Driving force minus the resisting forces. So, for example, 1000 newtons minus the resistive forces, we can add them up. 200 newtons and 300 newtons. 300 newtons. So the resistive, oh, the resultant force on the car is what? Is 500 newtons. So the resultant force on the car is 500 newtons. Type. This means A. Okay, if you have a positive resultant force, if you have a positive resultant force, this means that the car is speeding up. The car is accelerating. If you have a positive resultant force, this means that the car is accelerating. So whenever, okay, let's write it down. Whenever the driving force is greater than the resistive forces, what happens to the car or what happens to the object? It accelerates. صح? It accelerates. طيب, what if it was the other way around? What if the resistive forces were greater than the driving force? Huh? يلا, what if the resistive forces were greater than the driving force? What would happen? The car would move. It would move in the opposite direction. لا, it wouldn't move in the opposite direction. It would decelerate. It would decelerate, meaning that the speed was decreasing. Okay, it's decreasing its speed. Speed decreases. Type. This is if you have the resistive forces greater than the driving forces. What about if you have driving force equal to the resisting force? If you have the driving force equal to the resisting force, then the car is moving at a constant speed. خلاص. يبقى the car is moving at a constant speed. When would the car be moving at a constant speed? If the driving force is equal to the resisting forces. خلاص. طيب. Constant speed meaning that you have zero acceleration. Okay, zero acceleration. طيب. Zero acceleration, constant speed, driving force equals the resisting forces. خلاص. طيب. Again, let's talk more about um, if you need to find the resultant force, if you need to find the resultant force for a free falling object. Okay, free falling objects on Earth. Okay, and I need to specify that they're falling on Earth, because if they're falling on the moon, for example, it would have a different case, a slightly different case. Okay, let's discuss both. Free falling objects. Free falling objects. طيب. If we talk about the moon, if we talk about the moon, on the moon, this would be the first case, and this would be the easier case actually. On the moon is much easier than on Earth. Why? Why is the moon much easier than on Earth? Because on the moon there's no atmosphere. On the moon there is gravity. خلي بالكوا, there is gravity, but there is no atmosphere. What does the atmosphere do? There's air resistance due to this atmosphere. Air resistance is a resistive force which keeps on decreasing the acceleration. But let's discuss it يعني further on. But on the moon you don't have any atmosphere, therefore there is no air resistance. خلي بالكوا, on the moon there's no air resistance. Okay? Resistance, meaning that if you throw an object, or if you just release an object above the surface of the moon, it will fall freely without any air resistance, and it will keep on accelerating until it hits the ground. It will keep on accelerating with a constant acceleration. هنا هقول له ايه? Constant acceleration until it hits the ground. It will keep خلاص. طب how can I draw the graph? How can you draw a speed time graph for a free falling object on the above the surface of the moon? Huh? This is the time in seconds, and the speed and the speed in meters per second. If you draw the graph of the speed time, if you draw the speed time graph for an object free falling above the surface of the moon, you'd find that the graph has a constant slope. Constant slope meaning that it has a constant acceleration. On the moon, for example, the acceleration is not 9.8 meters per second squared. No, definitely not. On the moon, it's about 1.6 meters per second squared. You're not required to memorize the number, but on the moon, it will fall with a constant acceleration. ليه؟ علشان you do not have any air resistance, no air resistance. But on Earth it would be a lot different. Okay, what happens on Earth? تعالوا let's discuss on Earth. Well, this is a very popular question. Okay, you have a lot of questions discussing this specific example. A man jumps from an airplane wearing his parachute. He doesn't open it yet. Okay, he opens it after a couple of seconds. When he jumps from the airplane, what happens? Let's draw the graph uh, uh, um, and start writing down each point very with يعني, with all of the details, with all of the very boring details in this graph. Initially, he will fall almost with a constant slope. Okay, initially he will almost have a constant acceleration. Let's just draw it كده. Constant acceleration. وبعدين after he's falling with a constant acceleration, okay, he starts falling with a decreasing acceleration, and then after some time he reaches a constant speed, terminal velocity, and then when he reaches after some, he wants to open his parachute. So what happens? His speed starts to decrease, okay, and then he reaches another constant speed or terminal velocity. Let's divide this graph into several points. From A to B to C, D, okay, E and F. Yeah. Very quick, very quickly. Actually, this graph is very, very important. Let's write it down. VIP. VIP. Okay, it's extremely important. Okay, VIP. From A to B, what happens, يا جماعة? Okay, from A to B, what happens? He jumps from the airplane. Okay, he jumps from the airplane. Initially, he has a constant speed, sorry, constant acceleration. Initially, he has a constant acceleration. So the speed is increasing with a constant acceleration. يلا. Speed increases with a constant acceleration. Why? Because initially for the first second or for the first 2 seconds, for example, the only force acting on him is his weight. يبقى speed increases with a constant acceleration. Why? Because the only force, okay, the only force acting is, okay, is what is his weight. Is his weight. طب where's the air resistance? لا, it hasn't started to act on him yet. The air resistance has not yet begun to act on him. Starting from B, starting from B, what happens بقى هنا? We need to say بقى some very very specific details. Starting from B, his speed starts to increase enough. When his speed increases, what happens? The air resistance also increases. You have to say it. As speed increases, air resistance increases. Air resistance, okay, increases. But when air resistance increases, this means that this is a resistive force. But when I find the resultant force F equals D minus R, you'd find that the F, which is the resultant force, keeps on decreasing. F equals D minus R. Let me write it down here again. F equals D minus R. As the resistive force keeps on increasing, the driving force is constant. The driving force is constant. As the resistive force increases, what happens to the resultant force? The resultant force decreases. The resultant force decreases. So as the resistance increases, which is a resistive force, it increases. The resultant force, okay? The resultant force acting on him or her طبعا decreases. On him decreases. meaning meaning what? Force equals ma. So can you find the acceleration? Yes, I can find the acceleration. Acceleration equals force over mass. The mass is constant, so when the resultant force is decreasing, therefore the acceleration is decreasing. Therefore ايش يا شباب؟ the acceleration is decreasing. Acceleration decreases. Okay, so as his speed increases, the resistive force increases, which is the air resistance, okay? Um, Therefore, the resultant force acting on him decreases and the acceleration decreases. So he's still, the speed is still increasing. Huh? The speed is still the speed is still increasing. His speed increases. Speed increases with a decreasing acceleration. Speed increases with a decreasing acceleration. Type until he reaches C. At C, the resultant force has increased. I'm sorry, the resistive force has increased until it becomes equal to the weight. At C, his خلاص يعني his speed has increased too much that his resistive force, which is the air resistance, has become equal to the weight. When the resistive force becomes equal to the weight, هنا at point from C to D, the resistive force is now equal to the weight. Air resistance is now equal to the weight. When the resistive force is equal to the weight, this means that the resultant force is zero. صح? The resultant force equals zero. Meaning, he's at rest. No, he cannot be at rest. He cannot be at rest. Meaning that he's falling with a constant speed. He's falling with a constant speed. يلا, with a constant speed. طبعا zero acceleration. You have to say that he's falling with a zero acceleration type. Acceleration. We can call this constant speed. There's another terminology for this constant speed. It's called a terminal velocity. This constant speed, you can call it a terminal velocity. Okay? Terminal velocity when he's falling with a constant speed in the air. تمام. طيب. The problem is this terminal velocity, this constant speed is too high. This constant speed from C to D is too high. If he hits the ground with this speed, probably he would be unalived. What does he do at D? At D, what does he do يا شباب? He opens his parachute. يلا, he opens his parachute. When he opens the parachute, what happens? Okay, why is the parachute why does he open the parachute? When he opens the parachute, the surface area increases. Okay, the surface area increases. And as the surface area increases, what happens to the air resistance? The air resistance increases. So starting D, he opens his parachute. What happens? His surface area increases. When the surface area increases, surface area increases, يعني air resistance increases. From D to E, his surface area, his resistive force, the air resistance increases. صح؟ air resistance increases more. Okay, now it's more than the weight, more than his weight. صح؟ Now, when the air resistance is greater than the weight, what happens? The resultant force will be negative. Now he has a negative resultant force. What does it mean that he has a negative resultant force? It means that he will start to decelerate. He has a what? A negative, a negative resultant force. Negative resultant force, meaning that he will start to decelerate. Okay, he decelerates. But not just any deceleration. Not just any deceleration. As his speed decreases, بصوا كده, as his speed decreases, what happens? The speed is decreasing, therefore the air resistance on him is also decreasing. Air resistance and speed are directly proportional. As the speed decreases, the air resistance decreases. يلا, يبقى I'll write it down. As his speed decreases, what happens? يلا, let's write it down. As speed decreases. As speed decreases, what happens? Air resistance. Air resistance decreases. Air resistance is the resistive force. Air resistance decreases. طيب. Therefore, the resultant force on him, instead of being, for example, negative 200 newtons, it becomes negative 150 newtons, becomes negative 100 newtons, negative 50 newtons. What's happening to the magnitude of this force? what's happening to the magnitude of the force? It decreases. But the resultant force on him decreases. The resultant force, oh, resultant force decreases. Resultant force decreases. Therefore, he's falling with a decreasing deceleration. So he's falling with a decreasing, with a decreasing deceleration. Yeah, decreasing deceleration. ماشي. Decreasing deceleration until what? Until his speed keeps on decreasing until the air resistance again becomes equal to his weight. Again, his air resistance will be equal to his weight. فين؟ Huh? At point E. At point E, his speed has decreased so much that the air resistance has also decreased and become again equal to his weight, and therefore he will start falling with a constant speed, but a much lower constant speed, which would be much safer for him to land with. يبقى from E to D, from E to F, I'm sorry, from E to F, what's happening? From E to F, what is happening? He falls with a constant speed again, okay, but a much lower constant speed, okay, a much lower constant speed again. Why? Because the air resistance is also equal to, air resistance is equal to his weight again, once again. طيب. Why is this graph VIP very important? It's an extremely important graph. The probability, the chances that you have this graph in your test are very high. The chances that you get this same exact graph, or if he tells you to describe what's happening from point A to B or from B to C or to C, okay, the chances are very high. Okay. Why is speed directly proportional to air resistance? Well, they have calculated it. Okay. It's an experimental value. Okay, they have done several experiments regarding cars and air resistance or whatever vehicles that are moving. Okay, whenever they move, they find that as the speed increases, the air resistance created also increases. That's why they try to make the cars and airplanes, and they try to decrease the air resistance as much as possible in order for these vehicles to travel at much faster speeds. Okay. طيب يبقى يعني quite quickly, this is the graph for an object, or a man, okay, jumping from a plane with air resistance. Definitely, if there was no air resistance, what would have happened? We would have drawn it in this way. Why? Because constant acceleration has no air resistance. He would fall with a constant acceleration. But هنا, because we have air resistance, there is air resistance acting on him. This is the graph this is the speed time graph. Okay, this is, I have to write down here speed, okay, in meters per second, and a time in seconds. Okay, what's your question?
هو يا مستر، في بتاعة المون هي ليه constant مش increasing؟
لا, it's not increasing. There is no there are no other forces that could increase the acceleration. For you to increase the acceleration, you need to, for example, decrease the mass. You need to accelerate more. لا, he's just falling, or you have a stone, for example, and you release this stone from above the surface of the moon. So there are no other forces other than the gravity that acts on this object. So the gravity is constant on any planet. On Earth, the gravity, or the gravitational acceleration, is 9.8 meters per second squared. On the moon, it's 1.6. This is the only force acting on it. This force will not increase or decrease on the moon. I hope that's better. تمام.
اه فهمت.
Okay. Yeah. Free falling objects. Let's quickly talk about a couple of other things in forces. For example, he needs you to find the force, or the resultant force, between two perpendicular objects. The resultant force due to two perpendicular objects, perpendicular forces, two perpendicular forces. He'd say, for example, you have force acting. It could be in forces, it could be in speeds, velocities. Actually, to be more accurate, it could be a speed, velocity, or a force. Um, for example, if a plane, okay, an airplane is traveling north at, let's say, um, let me give you some not so intricate numbers, at 60 meters per second. Okay, بلاش 60, at 40 meters per second. Okay, at 40 meters per second, and some air, okay, some wind uh, pushes the plane. Okay, pushes the plane, pushes without an e, I guess. Okay, it's with an e. Pushes the plane, whatever. uh, um, pushes the plane at 30 meters per second due west. Find the resultant velocity or force, whatever, it doesn't really matter. Huh? Find the resultant velocity. You can draw a diagram. Okay, it doesn't have to be an accurate diagram, but you can draw this diagram. Okay, this diagram would be ازاي? You have a force acting, or you have a speed acting at the plane is traveling north 40 meters per second. North 40 meters per second. صح؟ طيب, and then the wind is acting west. طب يا مستر انا I don't know the difference between north, south, east, west. West is to the left. طيب, يبقى it's acting west at 30 meters per second. I need to find the resultant. The resultant would be wherever you started until you ended. يعني we started هنا and we ended at this point. يبقى خلاص, يبقى it starts here and ends here. This is the resultant velocity or resultant force. If يعني this could be in forces also. There's a some sort of force acting 40 newtons and another force is 30 newtons. خلاص يعني you would find it in terms of forces. Um, 30 meters per second and 40 meters per second. Find the resultant speed. How can I find it? Using the Pythagorean theorem. Okay, you can find it using the Pythagorean theorem. Is a square root resultant velocity. It would be square root a squared plus b squared, or 30 squared plus 40 squared. Square root 30 squared plus 40 squared is 50 meters per second. صح? 50 meters per second in this direction. So this is the resultant velocity v. The resultant velocity v in meters per second. The second question would be, I need to find the direction. You need to find the direction. Can you find the direction? Yes, you can find the direction. Okay, but the direction is, you can't say that the direction is north west. Okay, you can't say that the direction is northwest. لا, you need to find the angle, the degrees. Yeah, he'd tell you with respect, huh? With respect to the vertical speed, or with respect to the horizontal speed, with respect to the vertical, or with respect to the west, for example, or with whatever. طيب, usually 99% of the questions the direction is with respect to the horizontal. يعني with respect to the horizontal, يعني he needs to find this angle. Let me use another color. He needs you to find this angle theta. Okay, he needs you to find this angle theta. يبقى find theta. How can you find theta? How can you find the angle? Okay, find the direction. He won't say find the angle, find the direction. How can I find the direction theta? Using trigonometry. Using trigonometry. If you have theta, you have the opposite and you have the adjacent. So tan theta, tan theta is equal to what? Opposite over adjacent. So usually, to make life a bit easier, usually I tell you find theta ازاي. Find theta, tan inverse I'm telling you, 99% of the questions, tan theta is equal to, theta is equal to tan inverse y over x. Hmm? Tan inverse y over x. Okay, 99% of the questions he would need you to find the theta or the angle with respect to the horizontal. If the angle was not with respect to the horizontal, if he tells you find the angle with respect to the vertical, for example, لا, okay, it would be tan inverse x over y. But I'm telling you, 99% of the questions, it would be in this form. Tan inverse y over x, or vertical over horizontal. يلا. Can you find the theta? Yes, you can find theta. Let me calculate it. يلا. Theta equals tan inverse 40 over 30, which is يلا tan inverse 40 over 30 is كام 53 degrees صح. Yes, 53 degrees. تمام. 53 degrees. بس يبقى this is a question, it's a very popular question. Okay, the numbers could differ, definitely could be a bit different, but it's a very very popular question. Find the angle, find the resultant force, find whatever, using finding the force using a, or finding the velocity, the resultant. Okay, v, let me write it down. This is the resultant velocity or resultant force. You could, okay, using Pythagorean, find the angle using trigonometry, and to be more specific, using the tangent. The Mister, what happens if I use sine or cosine? Well, I found the velocity v. I found the resultant. I found the hypotenuse. Can I use sine or cosine? You could. You could do that. But the problem is, if your final answer was wrong for any reason, if your resultant force or resultant velocity was wrong, then you would find another wrong answer and you'd lose 3 or 4 marks. I could find you could يعني at least take 1 or 2 marks using or finding the correct answer using tan inverse. So I'd prefer for you to use the trigonometry, more specifically using the tangent, not the sine or the cosine. Okay? طيب. Um, uh, no. Actually, no. This is not a separate. This is not a separate session. No. This session. Um, this part is included. Okay, is included with the forces when we explained it back in the day. Another quite easy part was the centripetal force. Okay, another quite easy part was the centripetal force. Centripetal, okay, force. This is the force acting on an object moving in a circular motion. If you have an object moving in a circular motion, it would have a centripetal force and a centripetal acceleration. Okay, whenever you have an object moving in a circular motion, whenever you have an object moving in a circular motion, the centripetal force or the centripetal acceleration would always be directed towards the center. صح? Towards the center. I have the object moving in a circle. Let's assume that this is a perfect circle. Okay. I'm assuming طبعا it's a perfect circle. Definitely يعني it's not. And this is the center of the circle. Where is my object? For example, this is the object. It's moving in this direction. Okay, it's moving in a clockwise rotation. Where is the centripetal force? دايما you'll always say that the centripetal force is always directed towards the center. This is the centripetal force. I'll call it FC, centripetal force. It's always directed towards the center. For example, if the object was at this position, the object if it was here, فين الcentripetal? Where is the centripetal force? It's towards the center. يلا, it's towards the center. This is the FC, centripetal force. If the object was at this point, again, wherever بقى صح, the centripetal force will always be towards the center of the rotation. Centripetal force will always be towards the center of the rotation. طب, that's one question. One very, very easy question. The other question is, what happens if for any reason the force, okay, the object does not continue in a circular path, if it loses contact with the path, if it slips, if whatever happens, okay, what would happen to the car? It would move in a tangent, okay, or tangent to that point. The car or the object would move a tangent to that point. So this is the motion of the car. This is the motion of this object at that point. هنا the motion of the object at this point would be in this direction. The motion would be in this direction. At this point, the motion would be in this direction. It would be tangent at that point. It would be at 90 degrees with the force, the centripetal force. It would be at 90 degrees. It would be perpendicular to this force. يبقى the centripetal force is always towards the center. The motion, okay, for example, it loses contact or whatever, خلاص it moves, okay, it won't move in a circular motion anymore. In which direction will it move? Will it continue in this circular motion? No, it will not continue in this circular motion. It will move in a straight line, tangent to the circle at that point. You can draw it. It doesn't need to be very accurate if you want to draw it. It doesn't have to be very accurate, but you have to know that it's tangent. It's 90 degrees to the centripetal force. خلاص this is the motion. Now this is the centripetal force. I hope that this part was quite easy. Anyway, centripetal force, you have some questions regarding centripetal force. You have some questions regarding the perpendicular forces. You have a lot and a lot and a lot of questions regarding the free falling motion on Earth, okay, with air resistance. But let's solve a couple of questions in your classified, okay? Let's solve a couple of questions. يلا, let's open up your classified paper 4, part 1, of course, okay? Open up your paper 4, part 1 on forces. Let's see. Let's start from the end again. Forces was page, moment, وبعدين okay. يلا احنا we need to solve a couple of questions on forces and then we'll move on to Hooke's law. يلا forces. Yeah, the last page was page 123. I think we solved this question together, but let's solve it again. Okay, I think we solved it together. Let me solve it again with you. Now, page 123. يلا open up. يلا quickly. Page 123. We have two forces acting on a different balloon. Okay, this is any. There was part A for this question. So anyway, this balloon, we had two forces acting on it, determine the magnitude and the direction of the resultant force on the balloon. Determine the magnitude, and طيب magnitude is easy. يلا magnitude هتبقى كام؟ square root. يلا find square root 0.4 squared plus 0.74 squared. Yeah, let me calculate it using calculator. 0.4 squared plus 0.72 squared will be 0.82. 0.82. This is the force, so 0.82 newtons. صح؟ 0.82 newtons. طيب يا مستر, he didn't specify in which direction. Relative to the horizontal. See? Relative to the horizontal. Whenever I say relative to the horizontal, it means that I need a y over x. يلا, tan inverse. يلا, theta equals tan inverse y over x. يلا, which is the y, vertical force, which is 0.74. يلا. I'm sorry, I think I calculated it wrong, you know. 74, it would be 0.84. I'm sorry, not 82. 0.84. Anyway, it doesn't matter that much. 0.84. Tan inverse 0.74 over 0.4. صح؟ يلا, let's calculate بسرعة. It would be 0.74 over 0.4, 61.6 degrees. 61.6 degrees. 61.6 degrees. That's it. That's it. It's a very easy question for extremely easy marks. For very easy marks. Okay. 0.84 newtons. 5% of your exam. 5%. يعني it's easy. يلا. Moving on to the previous question. Okay, this had part A هنا. this had part A. Hmm. اه ايوه. You have a question? Hmm. You have a question? Hmm. Okay. طيب.
اه مستر معلش، هو تقريبا last question. احنا عملنا فيه حاجة غلط أظن.
Did I do wrong calculation؟ ليه؟
تقريبا أصل هي opposite over adjacent صح؟
Uh, opposite over adjacent. Yes.
أيوة، والopposite اللي هو ال 0.4 والadjacent ال
لا بص بقى. No, that's
0.74.
that's the problem. هنا you need to draw the triangle correctly. You actually need to draw the triangle correctly. If you start off with the horizontal force, it would be in this direction, 0.4, and then you draw the vertical force moving this way. This is 0.74 newtons. To find the resultant would be in this direction. This is the resultant, okay? And the theta
اه
with the horizontal would be this angle. So the opposite, this is the opposite, and this is the adjacent.
تمام اوكي.
Okay?
تمام thank you.
Okay. You're welcome. Yeah. Moving on to the previous question. هنا. An airplane accelerates along a horizontal runway before taking off. The airplane accelerates for 35 seconds. The speed of the airplane when it takes off is 72 meters per second. يلا. Define acceleration. يلا, that's an easy definition. What is acceleration? It is the rate of change of velocity. صح؟ يلا. Rate of change of velocity. ماشي. Calculate the average acceleration of the airplane between 0 and 35 seconds. Acceleration is what we said, average acceleration. طب مستر انت you said that the acceleration uh, is the slope صح? Yes, it is the slope. But for this question, when he asks you to find the acceleration or the average, so the average acceleration, the average acceleration, all you need to do is find the total speed over the total time, and that's it. Like average speed, total distance over total time. Average acceleration, total speed over total time, and that is it. You do not need to draw a tangent at any point. If he specified, if he told you find the acceleration at, let's say, time 5 seconds. At 5 seconds, you need to go up and draw a tangent and then find the slope of this tangent. Yes. But he didn't specify. He said find the average acceleration. خلاص, I will find the average acceleration. يعني I need to find the total speed over the total time. صح؟ يلا. Speed 72 over 35, which is around 2.1. صح؟ يلا. 72, I'm sorry, over 35.
2.05.
Yes. Okay. 2.1. Please do not forget the unit. Meters per second squared. Meters per second squared. Yeah, it's one mark. That's why it's very easy. The combined mass of the airplane, passengers, and 1.1 times 10 to the power of 5 kilograms. Calculate the average force. يلا, we know how to find the force. F equals MA. The mass is 1.1 times 10 to the power of 5 times the acceleration, which is 2.1. صح? This would give you around 230,000 newtons. It's a huge number. Do not write it as 230,000. It would be better if you write it as 2.3 times 10 to the power of 5 newtons. Okay? It would be better if you write it down that way. Okay. The force provided by the engines of the airplane is constant. خلاص, we have a constant force. It's the same force provided. Give one possible explanation for the change in acceleration. طب ما انت you had a constant force. Why wasn't the plane moving with a constant acceleration? يعني why didn't we just draw it as a constant slope or a constant acceleration? What is one possible huh, what is one possible يعني ما the plane, it's moving in air. It's moving in air, and we know that as speed increases, what happens to the air resistance? It also increases. صح؟ يلا. طبعا it's due to the air resistance. صح؟ Air resistance keeps on increasing. when the speed increases. As speed increase. Type on figure 1.2, sketch a graph to show how the acceleration of the aircraft varies between 0 and 35. Sketch a graph to show how the acceleration how the ايش يا شباب؟ how the acceleration varies between 0 and 35. طيب what's happening to the acceleration? What is happening to the acceleration? It is decreasing, صح? It is decreasing. طيب يعني as the speed increases the acceleration ايه decreases. That's it. That's all you need to say. I would rather decreasing acceleration. Yes, this is an acceleration time graph. Let me he wrote down هنا this is acceleration and this is time. Okay, so we need to draw an acceleration time graph. Yeah, but what happens? Okay, probably, okay, he reached a constant speed. Let me just check it. Okay. Uh, the speed, the airplane accelerates. The speed of the when it takes off is 72 meters per second. Speed. We will assume that he reaches a constant speed. That we will assume that he is reaching a constant speed. What's happening to acceleration? It decreases. Okay. Ah, oh, I'm sorry. Okay. Yes. Initially, he was falling with a. I'm sorry. Something's happening with the. Okay. Hmm. The acceleration initially was constant. Initially, he had a constant acceleration. طب why initially did he have a constant acceleration? It wasn't decreasing على طول. لا, initially he had a constant acceleration. طب how do I know that initially he had a constant acceleration? Because initially هنا you had a constant slope. صح? Initially he was moving with a constant. This is a constant acceleration. Initially he had a constant acceleration. Then after a couple of seconds what happens? The acceleration decreases. يبقى في الأول كده you had a horizontal line, you had a straight line, then it will start to decrease. صح? Then it starts to decrease. طيب يلا, it starts to decrease with a decreasing acceleration. Yeah, that's it. Okay, sorry, at 35. I'm sorry, not here. It should end around 35. Okay, just right after 35. It could reach 0 right after 35. This is not a straight line يا جماعة. This is not a straight line. This is actually a curving line. This is a curving line which would reach 35 0 after 35. Okay. It wouldn't make a difference if it's a curve or not. No, no, it wouldn't make a difference if it's a curve or not. Actually, there is there's a huge possibility you could actually draw it as a straight line. Okay, but do not reach the 0 at 35. At 35, he has not yet reached 0 acceleration. But that's it. تمام. It's a new question. It's a new question to draw the acceleration time graphs. احنا we are not very used to acceleration time graphs, which is okay, but that's why we are revising. That's why we are solving a lot of questions. صح؟ طيب يلا بينا. Previous question. Okay. Hmm. Well, constant, yes, constant speed means zero acceleration. Constant speed means zero acceleration. صح؟ ماشي okay, I do I understand what you mean. انت you want to draw it this way? ماشي انا فهمت. Okay. Yes. Okay. انت you mean you want to draw it something like this. Yes. Um okay, that wouldn't be wrong. Okay, wouldn't be wrong على فكرة. Because if you check, okay, if we draw it this way, it wouldn't be 100% wrong. That would be quite correct. ماشي. Because you have this point. This part is also constant acceleration. This part is also constant acceleration. ماشي, مش مشكلة. Um, good thinking. Good thinking. Thank you. Yeah. Previous question. Calculate the maximum acceleration during the first 100 minutes. Calculate the ايه؟ The maximum acceleration. طب how can you find the maximum acceleration? How can you find the maximum acceleration? All you need to do is find the acceleration of the constant part. All you need to do is ايه يا شباب? Find the acceleration of the constant part. طيب, where is the constant acceleration? From this point, let's say to around this point. Okay. Yeah, this could be considered a constant acceleration. Let's zoom in. Okay, let's zoom in. Yes, you can find the acceleration. Yes, we can find the acceleration between 40 and 60 minutes. Huh? Minutes, not seconds. Minutes, not seconds. Yeah. Y2 minus Y1 over X2 minus X1. But please take into consideration that this is 60 minutes. So you need to multiply by 60, which would be 3,600 seconds. And then 40 times 60, which would be 2,000, 2,400, huh? Seconds, okay? Please do not forget this point. At 60, he had a speed of 15 meters per second. At 40, he had a speed of six, 7, just below 7, which is around 6.75. Okay. طيب. If this isn't that accurate, خلي بالكم, if this isn't that accurate, what could you do? You can take this point, the point right after it, اللي هي at 42. This would be very accurate. This would have a speed of 15. Sorry, 7.5 ولا إيه. This would have a speed of 7.5. The point right after it, okay, would have a speed of 7.5. But can I find, oh, this is not 40, but this would be 42 times 60. This would be 42. Oh, this is 42 times 60. Yeah. Now we have the points. Yes, we do have the points. 42 times 60, which is 2,520 seconds. But we have time and we have acceleration. Yalla, V minus U over delta T, which is the change in time. Yalla, 3,600 minus 2,520 over, I'm sorry, I 15 minus 7.5. 15 minus 7.5 over 3,600 minus 2,520. It would be a very, very small number. عادي. 7.5 over 3,600 minus 2,520. 6.9 times 10 to the negative 3. 6.9 times 10 to the negative 3 meters per second squared. عادي. Okay? It's a very, very small acceleration. طيب. Easy. Calculate the distance, or calculate the total distance traveled by the ship between time 42 and time 100. Calculate the total distance between 42 and 100. يلا, total distance meaning total distance meaning area under the graph. صح, area under the graph between 42 and 100. طيب, between 42 and 100, between this point. يلا, شفتوا بقى, this is a very accurate point. يلا, between 42 and 100, يعني we need to find the area of a trapezium. طيب يا مستر, I don't want, I need to find it as a couple of shapes and I want to divide it into several shapes. خلاص, you can divide it into several shapes. Actually, it would be more accurate to divide, يعني, because this isn't actually a trapezium. يلا, if we divide it into this shape, this is a rectangle, and then this shape, which is another triangle and another rectangle. We have two rectangles and a triangle. Yeah, let's find the areas. Okay. لا, it's not a trapezium. No, it's not a trapezium. Okay, let's find these areas. يلا, we have هنا A1, we have A2, and we have A3. Let me write them down هنا to make life easier. A1 is a rectangle, so it's length times width. The length is from 100 to 42. From 100 to 42, that is كام? That is 58. صح? 100 minus 50. So that's 58 times 7.5. That's a area 1. Whatever it would be. What's area 2? It starts at 60 and ends at 100. طيب yeah, but this is easier. 40. يلا, this is area 2. 40 times كام؟ 7.5 عشان it starts at 7.5 and ends at 15. يلا. 40 times 7.5. خلي بالكوا. Area 1, what did I do? It started at 42 and ended at 100. So how did I get this 58? It was 100 minus 42. Okay, the area 2, 40 times 7.5. Area 3, this is a triangle, half times base times height. The base starts at 42, ends at 60, so it's 18 times 7.5. How did you get this 18? عشان 60 minus 42. يلا calculate بقى بسرعة. يلا let's calculate them بسرعة كده. 58 times
مستر
7.5.
هي مش الاريا بتاعت التريانجل المفروض half times base times height.
Half times base times height. I didn't multiply by half. صح, شكرا. I didn't multiply by half. Yes. Okay. Thank you. 58 times 7.5 is 300. 435. بس يا مستر, انت there's something wrong you didn't do. Yeah, Mr. Enta, you didn't multiply the time by seconds. You need to multiply these areas by 60. All of these areas are in minutes. They are all in they're all in minutes. We need to multiply all of these areas by 60. يعني whatever number you find, okay, you can just add them up and then multiply by 60. It's okay. You can multiply each of these areas by 60 and then add them up. It doesn't really matter. خلاص, but do not forget to multiply by 60, please. Why? Because the time is in minutes and you need the time to be in seconds. You need the time to be in seconds. You have to multiply by 60. So 58 times 7.5 is 435. And I will just add them up and then multiply by 60. Okay, 40 times 7.5 is 300, and then I'll multiply by 60 again. 18 times 7.5 times half, 67.5. Yeah, let's add them up. 45 plus 300. Yeah, it's 802, 802.5. And then I'll multiply by 60 times 60. It's a huge number, 48,150. So the total area, هي times 60, 48,150. عادي. طيب, total distance traveled, 48,150. You can write it down in a simpler form. Okay, you can write it down in a simpler form. 48,000. That's it. You can, instead of writing 48,150 meters, you can write 48 kilometers. So you can write it as 48 kilometers. That would be much better. صح? Or 4.8 times 10 to the power of 4 meters. Don't just write too many numbers. Okay? Don't write too many numbers. يلا. سهل. يلا بينا. هم.
ممكن
add.
حضرتك ترجع ثانية؟
بسرعة. هنا.
لا، فوق شوية اللي هي عند الاريا.
الارياز. يلا بسرعة. هم.
تمام يا مستر.
اوكي. يلا بينا يا شباب. هنا. For the next question, he needs you to find he needs to find the resultant force. يلا. You have the acceleration and you have the mass. خلاص, it's as easy as that. صح? F equals ma. We just multiply both numbers. F equals ma. Just multiply. يلا. 2.3 times 10 to the power of 7. 0.0087. It would be huge number. 2 times 10 to the power of 5. 2 times 10 to the power of 5 newtons. Okay. ماشي. يلا, explain why the force on the ship due to the ship's engine is greater than the value you calculated. The actual force would be greater. The actual force, the actual driving force would be greater the resultant force. احنا دلوقتي we found the resultant force F equals ma. This is the resultant force. This is not the actual force on the engine. This is a ship moving in water. Is there any resistance? Yes, there is resistance. Due to what? Due to air, due to water, whatever drag you can call drag. So there is a backward. It's an opposing force. There is an opposing force due to the water. يلا. Opposing forces. أو instead of opposing forces, resisting forces due to water. يلا, that would be better. يلا. Resisting forces due to water. Okay? Resisting forces due to water. يلا بينا. خلاص. Easy. طيب. Let's move on to Hooke's law. Okay. Let me explain بقى شوية Hooke's law علشان I don't want the session to be too long. Okay. I don't want it to be too long. يلا بينا. Hooke's law. Okay. For Hooke's law, شباب, most of the questions he needed you to find the extension. Okay, he needed you to find the extension. How could I find the extension? Okay, extension equals what? Equals the extended force or the length minus the original length. The extended length. Okay, it's the extended length minus a minus the original length. So, for example, you had a spring. Okay, the original length of this spring was 15 centimeters. The extended length, okay, the extended length is due to force of let's say 20 newtons or 10 newtons, whatever, is 19 centimeters. So the extension would be 19 minus 15, which is 4 centimeters. So this is the extension. What is Hooke's law? Okay, what is Hooke's law? Hooke's law, أو يعني إيه, the definition of Hooke's law is that the force and extension are directly proportional unless reaching what? Unless reaching the limit of elasticity, unless reaching the elastic limit, unless reaching the elastic limit. طيب, how can I calculate the force, the Hooke's constant or the spring's constant? How can I calculate the spring's constant? F equals kx or k equals f over x. K equals f over x. What is f يا شباب? It is the force and x is the extension. It has to be the extension. That's why I say that Hooke's law is that the force and extension, force and extension are directly proportional. Not force and length, not force and whatever. لازم force and force and
مستر
extension. نعم.
هي كي ديت اللي it stands for what?
ايه؟
K stands for what?
K stands for the Hooke's constant or the spring's constant. Okay? Yeah. This is the spring's constant. Yeah. Spring's constant type. What is the spring's constant? The spring's constant is an indication of how strong the spring is. Okay? It's how strong the spring is. If you have a much higher if you have a much higher springs constant, then the spring will be much stronger. You cannot easily extend or compress this spring. خلي بالكوا, you cannot easily extend or compress the spring if you have a much higher springs constant. The lower the springs constant, the easier, okay, it is for you to extend or compress this spring. Okay, that's it. The springs constant. Can I find the springs constant? Yes, you can. F over x from the graph, whatever. But how can I draw a directly proportional graph? Okay, to draw a directly proportional graph, you need to have هنا, for example, الفورس in newtons and هنا x in centimeters. A directly proportional graph would start from the origin. It would start from the origin and move in a constant line. Okay, you could draw it this way, or you could also draw it. You could flip the axes. يلا, I can flip the axes. You can draw هنا. And force and extension would be on the x-axis, and it would also be a straight line. طيب, this is a straight line. Oh, both of these are straight lines. Both of these graphs are directly proportional unless reaching the elastic limit. If the spring reaches the elastic limit, when the spring reaches the elastic limit, what happens? What happens after the spring reaches the elastic limit? How does the curve behave? How does the graph behave? It starts to curve. It is no longer obeying Hooke's law. Huh? It's no longer obeying Hooke's law. What does it mean that it's no longer obeying Hooke's law? It means that the spring is no longer, the force and the extension are no longer directly proportional. It means that with a very small force, a very small force, you can extend the spring much longer. With a very small force you can extend the spring much longer. That's when you خلاص you're no longer obeying Hooke's law. That's when you reach the elastic limit. That's when you exceed the elastic limit. Like, if this is the elastic limit, let me draw it using another color. If this is the elastic limit, this point is the elastic limit, how will the graph behave? It will curve towards the towards the extension axis. Towards the extension axis. It's curving towards the extension axis. Oh, at this point, it's curving towards the extension axis. The extension axis type. Yeah, this one will curve downwards. Okay, this way. Okay, يبقى it will curve towards the extension axis. Why? Because this is the elastic limit. This is the elastic limit. It could be called the elastic limit. It could be called the limit of proportionality, the limit of elasticity. It has many names. Okay, يلا, this is the limit of proportionality. Oh, limit of proportionality. They're the same point. They are the same point. So if he says, for example, that the elastic limit of this spring is at 50 newtons, for example, it's at 50 newtons. خلاص يعني if you add a force of 60 newtons to this spring, what happens? خلاص, it will plastically deform. It will plastically deform, meaning that it will no longer return to its original shape. It will no longer return to its original shape. Elastic deformation means that I can change the shape and then it will return to its original shape. That's what I mean with if I say a elastic deformation. But plastic deformation means that I will change the shape. Yes, but I will no longer return to the original shape. So for springs, we usually need elastic deformation. We need the spring to return back to its original shape. If we have a rubber band, I need the rubber band to return to its original shape. What happens if it exceeds the elastic limit? What happens if it exceeds the limit of proportionality? خلاص, it will break. It will no longer return to its original shape. That's it. يبقى usually احنا we do not want to exceed the limit of proportionality. We do not want to exceed this elastic limit. What happens if it خلاص it will bend towards the it will bend towards the extension axis. It always bends towards the extension axis. طيب, what else? Okay, what else? شباب, there's a very special case, if you have two springs. If you have two springs, okay, if we have two springs, they could either be in parallel or they could be in series. بصوا, they could be in parallel or they could be in series. طيب, what happens if they are in series ولا إيه؟ If they are in series, this is the first spring and then this is the second spring, okay, and I add a force of, let's say, 10 newtons. Okay, طيب, if I have another case of these springs being in parallel, okay, these springs are in parallel. Oh, and I added a force of 10 newtons. A force of 10 newtons. If the springs were in series, what happens to the total length? The total length, or the total, I'm sorry, not the total length, the total extension is multiplied by 2. هنا, if you have them in series, the total extension, okay, is multiplied by 2. So, for example, if each spring extends 2 centimeters if each spring extends 2 centimeters, so this will extend 2 and this will extend 2. So the total extension would be multiplied by 2. But if they are in parallel, each spring will extend, the total extension would be divided by 2. The extension would be divided by 2. Oh, divided by 2. Why? Yeah, why would the total extension be divided by 2? Because it's as if you're saying that each spring has a force of only 5 newtons. It's as if you're saying that each spring, شباب, huh? It's as if we can divide the diagram. Okay, so each spring will have a force of only what? Of only 5 newtons. Ah, this is only 5 newtons هنا and 5 newtons هنا. So each spring will have only half of the load, so it would extend only half of the distance, half of the extension it was initially, or it would have extended. يبقى if they are in series, you multiply it by 2. This is in series, you multiply it by 2. If it's in parallel, what happens? You divide it by 2. That's it. Okay? يبقى that's very, very quickly what happens in Hooke's law. Okay? I know we don't have that many questions regarding forces and extension. We don't have that many questions regarding Hooke's law. بس خلاص, it's okay, معلش يعني it's part of our syllabus. We have to explain it. Okay? We have to explain it. خلاص, F equals kx or k equals f over x. This is the spring's constant. How can I find the extension using length minus the original length? I can find it from the graph. خلاص, I can find it from the graph, even if I have another different graph using the length and force graph. طيب, let's solve a couple of questions regarding Hooke's law, and if we have time, we might go back to the forces. Hooke's law, and let's open up. Okay, the last question and move backwards. يلا. Let's open up the last question and move backwards. Quickly كده يا شباب. Okay. The last question هنا was in page يلا page 140. صح? This was the last question in page 140. Okay. يلا. Did you all open it up? Page 140. ماشي. يلا بينا. Let's start. Determine the spring's constant of this spring. Can you find the spring's constant of this spring? Oh, خلاص, it's easy. K equals F over X. Type. If you had several numbers, and if I had, for example, هنا 7 and 2, could I have taken any two numbers? Yes, you could have taken any two numbers. Why? Because this is a directly proportional graph. Directly proportional means that the numbers are or have the same rate, or you can write it down as a ratio. So the ratio would be equal for any point. Okay, it would be equal if you take مثلا 1 and whatever number is with 1 ماشي, 3 and whatever number is with 3 تمام. Okay, but that's what we mean. Okay, when we say directly proportional, a ratio, it's constant. Okay, F over X, so 14 over ايه ده, I'm sorry, 14 over ايه, 14 over 4, يلا 14 over 4, which is 3.5. طيب, again, do not forget the unit. صح? Do not forget the unit. The unit of the force is newtons, and the unit of the extension in this graph is centimeters. So it's Newton per centimeter. If the graph, okay, if the extension graph or the extension axis was in millimeters, we could have used per millimeters. خلاص, يبقى 3.5 newtons per centimeter. Mark the limit of proportionality and label this point L. Mark the limit of proportionality and label this point L. خلاص, that's easy. It's almost at the end of the straight line, almost at this point. Okay, this could be point L, the limit of proportionality or the elastic limit. صح? Or the elastic limit. يلا, this is point L. يلا, on figure 2.2, mark. يلا, mark with an arrow the direction of the resultant force acting on the car as it travels around corner A. The car is traveling. Is it traveling in a horizontal line? No, it's traveling in a circular motion. Oh, circular motion means that there is a centripetal force. صح? there is a centripetal force. يبقى it would be moving أو the force would be some in a sort of this direction. صح. يلا. This is the force acting on the car. It's a centripetal force. صح. Centripetal force. طيب. Corner B has a smaller radius. It has a smaller radius. The car travels at the same speed. State how the resultant force changes. Okay. How does the resultant force change? والله as the radius decreases. بصوا. As the radius decreases, the force acting on the car actually increases. Huh? The centripetal force acting on the car increases. It would be much more difficult for the car to travel in this on this يعني graph. فit would be much more difficult for the car to travel. The force acting on it would increase whenever the radius decreases. Okay. يلا. Moving on to the previous question. They are both related to each other. يلا. A force is a vector quantity. State two features of a vector quantity. يلا. This is an easy question. يعني. What are the vectors? It has a magnitude and a direction. صح. A magnitude and a direction. يلا. State the names of two other quantities that are vectors. Any two other quantities. يلا. Weight and momentum.
Momentum.
Okay. حلو. Momentum. And let's say acceleration.
Velocity.
Hmm?
Velocity.
Velocity. Yes. Okay. Um. يلا. حلو. We had this apparatus. We had the initial length. Okay. And we keep on adding some weights to the spring. This is a length weight or a length force. Um, this is a length force graph. He wants you to find the original length. Okay, he wants you to find the original length. Can I find the original length? Yes, I can find the original length using you can find the original length using the graph from the y-axis. صح. يلا. From this point, this would be the original length. هنا it's 0.1, 0.12. 0.12 and do not forget the unit meters. 0.12 meters. جميل. 0.12 meters. State what is meant by the limit of proportionality. يعني ايه كلمة limit of proportionality؟ يلا احنا we need to define the limit of proportionality. It's a point. Okay, a point at which if the force is increased or if the force increases above this point or if the force increases above this limit, what happens? The spring is no longer obeying Hooke's law. The spring is no longer directly proportional. Okay, the point at where spring is no longer obeying Hooke's law. Yes, that is correct. صح. Point at which the spring is no longer obeying Hooke's law. Yeah, a point at which the spring is no longer obeying Hooke's law. طيب. حلو. Good. Can you find this point? Can you find the weight at which this point, at which the elastic limit is? Yes, from the graph. It's not 10. لا, it's after 10. مثلا around هنا. Maybe at this point. Okay. Maybe I guess this is what 10.6, around 10.6. Maybe greater than 10.6, less than 10.6. Okay. Yeah, within this range. ماشي. So 10.6 newtons. Do not forget the units. Yeah, 10.6 newtons. طيب. Can I find the spring's constant? Yes, حاضر. I can find the spring's constant. It's not that hard خالص. يلا. I can zoom in شوية. طب do I have to use بص يا شباب. Do you Is it a must for you to use this point 10.6? لا, it's not a must. Can I, for example, use this point? Oh, this is much easier. This point is much easier. At 10 newtons it had a length of 0.56 صح. خلاص يا مستر يبقى k equals f over x 10 over 0.56 صح. لا, that's wrong. That would be wrong. ليه? Why would it be wrong? Okay, why would it be wrong يا شباب؟ ركزوا عشان k equals f over x not f over l. k equals f over x. So the force is 10 newtons. ماشي جميل. Is the extension 0.56? لا, the extension is not 0.56. How can I find this extension? Huh? How can you find the extension? It's the length minus the original length. The length minus the original length. So it's 0.56 minus 1 point, minus 1.2. Is this 0.56? لا, this is 0.54 يا جماعة. I'm sorry. This is 0.54, not 0.56. I count. This is 0.54. Yes, yes. 0.54. So 0.54 minus 0.12. minus 0.12. خلاص. يبقى let's calculate it كده بسرعة. 10 divided by يلا. هيبقى كام؟ it would be 23.8. 23.8 اليونت. do not forget the unit. نيوتنز. وهنا ايه؟ is this سنتيمترز ولا مليمترز؟ this is meters اصلا. 23 خلاص يبقى meters. يلا 23.8 newtons per meters. يلا 23 newtons per meter. easy. I hope it's easier. okay, يلا بينا. previous question. Moving on to the previous question. State Hooke's law. Yeah, that's easy. State Hooke's law. Force and extension are directly proportional. Yeah. Force and extension are directly proportional unless reaching the elastic limit. Unless reaching the elastic limit. صح؟ Elastic limit. Easy. يلا. Force and extension are directly proportional unless reaching the elastic limit. جميل. Next question. Mark and label the region where the spring obeys Hooke's law. Until up to which point does it obey Hooke's law? Up to which point does it obey Hooke's law? 20 maybe. It's a bit after 20. It could be a bit after 20. Around maybe 21. For example, this point. ماشي. Or 20.5. I guess would start to curve at this point. Maybe 20.5. Okay, maybe up to this point. So this is 20.5. Yeah. This is the springs sorry, the elastic limit. طيب. Any point on the graph. لا, he wants you to specify the region. Okay, he wants you to specify the region. يعني mark and label the region where the spring obeys. يعني it starts from zero. Okay, it starts from zero all the way up to the elastic limit. All the way up to elastic limit. This is the obeying Hooke's law. كل ده, this is obeying Hooke's law. يلا. Okay. يلا. ماشي. Calculate the spring constant K. يلا, K equals F over X. K equals F over X. يلا, F whatever F and whatever X you want. Also whatever X and yeah, just take 2 points. Just take 2 points from your graph. يلا. مثلا let me take this point. يلا. Seems about right. This is 10 صح. And هنا it would be 50 60 70 صح. صح. اه ماشي ماشي. I think this is right. Okay. يلا 10 over 10 over 10 over 70. يلا what's 10 over 70? I guess it's 0.14. 10 divided by 70. Yes, it's 0.14. What is the unit? 0.14 newtons per هنا meters millimeters. 0.14 millimeters. بس okay. 10 over the original length of the spring is 120. Calculate the length of the spring when a load of 8.5 newtons is applied to the spring. يلا سهلة. When a load of 8.5 newtons is applied to the spring. فين 8.5؟ حاضر 8.5. يلا let's find 8.5 on the graph. هنا ده 5. This is 6 7 6 7 8 8.5 at this point exactly. يلا move up. We need to find this point exactly. يلا this point exactly would be 60 صح. This would be exactly 60. طيب يعني the extension is 60. خلاص the length is 60. لأ. This is the extension. You need to add the extension 60 to the original length. يبقى 60 plus 120 is 180 millimeters. Okay? Please, again, at 8.5, you need to find exactly where 8.5 is. هنا 8.5, this is 8.5. So draw a line, okay, a very accurate line using a ruler and a very thin pencil, okay? And at this point, you'd find that the extension is the extension is 60, okay? Easy. طيب. يلا يا شباب. يلا يا شباب. Okay, خلاص. The weight of an object is 4 newtons on a planet where the acceleration is 8.7. يعني quite يلا. Can I find the mass? M equals ايه؟ واحنا we know that weight equals mg, so m equals weight over g صح. 4 over 8.7. يلا 4 over 8.7 كام؟ 4 divided by 8.7 0.46. يلا 0.46 ايه نيوتنز. شباب احنا هنا we will not use 9.6 9.8. We will not use 9.8. ليه؟ عشان this is on a
مستر ازاي
different planet.
الماس بالنيوتنز؟
ده مستر نيوتن.
I'm sorry, not newtons. برافو عليك. Thank you. Okay, it is in kilograms. بس okay, the G يا شباب is not 9.8. The G is 8.7 عشان this is a different planet. Yes, definitely the mass is in kilograms. Okay.
مستر انا ازاي عرفت انها ان كيلوغرامز ومش جرامز برضه؟
نعم.
ازاي عرفت انها ان كيلوغرامز ومش
In
جرامز؟
kilograms because the SI unit of the mass, SI unit is SI unit is kilograms. So if the weight is in newtons and the G is in meters per second squared, G is meters per second squared, and the weight is in newtons, so definitely the mass will be in kilograms. Okay.
مستر هو احنا ليه مش عملناها F equals MA؟
ما على فكرة this is the same equation على فكرة. Yeah, it's the same equation. F equals ma. F is the weight. When weight is a force. Weight is a force. صح. And A acceleration, the free fall acceleration, which is G, but on another planet. So if you want to find M equals F over A, it would be the same. 4 over 8.7. Okay? Yeah,
اوكي
technically it's the same equation.
ماشي.
تمام؟ اوكي يا شباب. Um,